Hello, everyone, and welcome to the very first Boring Enterprise Nerds Show and Tell. Yes, you are not in kindergarten anymore. This is Show and Tell for adults and grown-ups to bring your favorite toys and treats to everyone to see how they're doing. So I am Paul Moderman. With me, as always, is Yelena Perfilieva. Say hi, Yelena.
Hello, everyone.
And our special, esteemed, exciting, amazing guest is Vadim Klimov. Vadim, please give us an introduction of yourself.
Hi, Paul. Hi, Diana. Hello, everybody. Nice to meet you here, and really pleased to be a guest on your show, on your podcast. My name is Vadim Klimov. I work as an independent consultant in the integration space. So predominantly, I'm focusing on SAP integrations, integration platforms, SAP PIPO, integration suite, and more recently on some other cloud technologies that sit around BTP and Asia and AWS. And here I'm with you to speak about event-driven architecture and hopefully to showcase how we can do some interesting stuff with event brokers, how we can deploy them, and how we can see them in action in the distributed environment.
That's beautiful. Let's not waste any time. Let's get to those juicy details. For watchers and listeners, there will be a few different segments in what we show here, and we'll mark them in the video. So if you're not interested in command line stuff, skip that part. If you're not interested in graphical business data distribution stuff, skip that part. But Vadim has a wealth of knowledge across those things. So we'll split this video up into segments for you to see those things. But with that, let me shut up and stop talking. Take it away.
Thank you. Let me share my screen. Okay, so let me just describe what is the simple event-driven integration, how it's comprised of, and what do we have. So we have a publisher, which is some application or service which emits events, and we have a subscriber or consumer. It can be one of them, it can be multiple, but these are parties, subsystems, applications which are interested in digesting those events and reacting to them. So it can be some processing, and they can also emit subsequent events, so they become publishers. And in order for them to talk to each other, we need an event broker in the middle. So those connections are never direct. They are mediated using the event broker. So we have the publisher who emits, publishes the event to the event broker, and we have a subscriber or subscribers who subscribe and listen to those events and do some useful stuff for them. Mm-hmm. That's the simplest form, and now we put it into the wild. So let's assume we have some vault around us. So publisher, event broker, and subscriber don't live in isolation, but they live somewhere in the vault. And in the simplest form, when we all publishers and our subscribers and are nearby, it's not a big deal. So we place event broker somewhere in the middle of them, and everything works well. But what if we start adding additional publishers and additional subscribers? And I will just refer to them as messaging clients, because for the event broker, it's some parties who publish, some others who consume. Commonly, they will do so using the same set of protocols and technical capabilities. So now we have to link those two as well, but those are quite far distant. So what shall we do then? Latency is one of the problems. Shall we move the event broker and apply some science behind it to calculate the minimal distance to all publishers and subscribers so that the latency is somehow distributed or averaged? That could be one of options. But now we start adding even more publishers and subscribers who live on different continents, and they're just placed everywhere, all over the world. So now we have a spider net. So now we need to figure out what do we do in this setup. Let's assume that we have some publishers and subscribers which are quite critical. Let's assume the first ones were more critical. So we need to guarantee the lowest latency possible. To them, does it mean that we need to move event broker back to its original state? But then we have latency problems to far distant integrated parties. And those are quite a lot from this picture. This is not very optimal. So what we need to do now is we need to think about how we can evolve the idea of a single event broker into multiple instances of those. And this is where we introduce event brokers, which are interconnected. And those event brokers provide services for publishers and for subscribers those which are nearest to them. So for example, in the US, subscriber doesn't need to connect to a European broker. It connects to the US broker. The same is for European, for Asian, for Australian, etc., etc. And as you can see, event brokers talk to each other, but not necessarily all of them have to talk to each other. So it may be the case that some brokers have segregated networks or maybe legal requirements, compliance, and they are not allowed to transmit data outside of a certain region or a certain country. So when we connect those brokers, we can do it in a smart way, in the way that we know which flows between brokers are allowed. And for publishers and subscribers, it becomes quite transparent because those are connected to the nearby broker or the broker which they can access. And if we need to make this setup even more distributed, we can keep adding those event brokers. We can deploy them, plug into the event mesh in here, and connect to other publishers and subscribers to them.
Sorry to interrupt. Just one question to help maybe our viewers to put this into some kind of business frame. What could be an example of an event? To my mind, I think like shipping confirmations and like order notifications are usual typical examples. Are there any examples that you could mention that like in the business context for this?
Good question. Formally, it's any significant, meaningful change of the state of the object, but that's too scientific name. So in reality, any change to master data, to transactional data, in IoT space, to some machinery data, this all can, those objects, they can produce events. So for example, a product got created, or a sales order got changed, or a vacation request got approved or rejected. Or it could be that some machinery emits a telemetry information. So, for example, certain values, and this can be anything: enterprise systems, operational systems, and so on. Also, they can come from different domains. So they can come from logistics, from production, from manufacturing, from sales and procurement, and so on and so on. So any events that happened within the application or a service, which this application or service would like other systems to be aware about, this is where they can decide to emit the event. And those others can react to it. So for example, a user can be created in a technical system, and then the event of this user creation can be of interest for the HR system. Or when the employee gets blocked, it may happen so that other systems need to be notified about it, and they need to apply certain action. And for example, some workflow systems need to apply certain action. Another example is the user sets out of office in the mailing client in Outlook, and the approval workflow engine needs to know that that user is out of office so that they adjust approval of workflows. So it can also be considered as an event for which the automatic change in approval workload can be applied.
That's interesting. Yeah, I wouldn't have thought about this. Yeah, but it's an interesting feature. Yeah, thank you so much. Please go ahead.
Yeah, actually, Vadim, well, now that we're jumping in and interrupting here, let me get one out there too, because I was curious, in your experience with these sorts of this mesh architecture here, what kind of like latency guidelines have you worked with for these various, like, okay, we need another broker here. Okay, we might need another broker here. Like, what kind of latency are people looking at when they're thinking about adding to their mesh structure?
I would say that for some integrations, relatively high latency is not a big deal. It's not a problem. So they can tolerate a latency of several hundreds of milliseconds. Or even seconds. But there are some interfaces, for example, in the machinery space, where the optimization is hundreds of microseconds.
Wow.
So they will require quite instant reaction. Also, there are some security events for which the reaction has to be almost instant. So, for example, if the user account got compromised, or if the security log logs itself, they can be sources of events. So, for example, there is some security log or access control in the building. And as soon as somebody touches the badge and the access system identifies that the badge was compromised, this event has to be as quickly distributed across the environment. For example, some notification to security system has to be thrown.
That's a cool scenario.
So those events would normally require quite a very quick response and very low latency.
Oh, yeah. Thank you for that.
Yes,
That's good
yeah.
examples for
So,
that.
Thank you.
and also there are some events which can occur not because we do something. For example, we created a new order or we changed a product master, but the time passed. So the passage of the time is the other example of events. For example, we booked a vacation which will start only a week after. And when a week passes, nobody changed anything, nobody created anything, but the event will be triggered so that the employee, for example, some system reactions can be triggered based on the fact that an employee started their vacation, which was booked some weeks ago. That's another example of events. More commonly, events are those which are triggered by action in the system, but again, passage of the time is another example where events can be triggered. And this is so you see that there are lots of areas where event can be produced. Another question is whether the system that emits the event is authoritative system. So, for example, we have quite a lot of systems that can change material master data in the SAP ecosystem. So it can be some core systems like MDM and ECC or S4HANA, but there can be some others. If the material gets updated or changed in those systems which are not MDM or S4HANA, this is also an event within those systems. So, for example, we can have above workflows triggered for those events. But whether those events, whether those systems are authoritative to emit the event about the product change outside of the system. So, for example, if the product got changed, we normally would have very specific systems in the landscape, events for which we would like to broadcast to the rest of the world, to the rest of systems, which means that only if the product got updated in that system, we think that now the product update happened and we would like other systems to be notified. Another example is employee master record. So quite a lot of systems may process different views or different attributes of the employee master, but only specific nominated systems like HR systems and a few others will be treated as authoritative, so that when employee master record gets updated in that system, this is the event which we would like to publish and to announce to other subscribers outside of that specific system or even domain of that system.
And
So
I think
not every...
Yes, sorry, this example that you mentioned of master data changed in different systems, I think it immediately introduces a whole like a black hole of side subject of data synchronization and serialization. Like it can happen sometimes that it happens almost simultaneously. People get access to the same data, they make changes that sometimes needs to be reconciled or maybe sequenced or maybe even put to some judgment like, hey, now you need to decide which one of those they happen at the same time, but they conflict. So I think I don't know if you were going to touch on it. If you do, that would be great. If not, I think it's also very interesting subject that maybe eventually we can talk about. But yeah, thank you so much.
This multi-source of the event, that's a very interesting topic. But as far as we get multiple systems that can update the same record in parallel, and all of them are treated as authoritative, then it's a challenge commonly, because then we can have event streams that are conflicting changes, and we technically we can compose the event stream which is sourced from multiple systems. Like, for example, events about product master data, which come both from MDM and S4HANA systems. And technically, we can put them in a single event stream about product updates. But effectively, commonly, we will have some segregation. So we will have to decide which attributes or which views of the product data or material master data are allowed to be changed in which of those systems, so that events for those changes are triggered and others are ignored. Or maybe they are used internally within the system, but at least they are not distributed within the landscape.
Awesome. All right, let's proceed.
Interruption's over.
Interruption is over.
No, I'm very happy. I'm very happy that you ask questions, because those are very interesting. I mean, my example will be quite technical, but it's good when you can put it in the context, in the business context, and when you see how it correlates and how it applies to real transactions, to real business processes. And in here you see that we have event brokers. They together they form kind of a grid, and this is commonly referred as event mesh. So those brokers compose the mesh which knows about events circulating within that setup. And then a few bullet points about where event mesh makes sense, because it sounds like, it looks like it's a great idea to have event mesh and this distributed infrastructure, but it has additional maintenance cost, and it has additional complexity layer. So not always this event mesh is fully required. So there are certain common reasons where we would think about event mesh as opposed to a single event broker or a very limited number of event brokers. Mostly it's when our landscape becomes too distributed between publishers and subscribers, and the quality of distribution, the distribution itself, it can come from different aspects. So it could be a geographical distribution, it could be network segregation. So for example, some networks may be highly isolated, not air-gapped, but segregated, and other publisher subscribers cannot easily get into that network. And commonly, it's a compliance requirement as well. So we just need to make sure that some events don't leave the boundaries of country or region, and also the dynamic nature of events routing, so that when we start adding new publishers and subscribers, we don't have extra maintenance costs to reconnect them or to manually set up forwarding rules for those events. Because if we think about how many different event types, event streams we can have in the large organization, and how many publishers and subscribers can appear, and they would normally appear over time, so they will not appear instantly on day one, so that we can plan in advance where we place the event broker. Commonly, they will get added over the time, and then for us to react to see how we can extend this setup of the event brokerage, and where else we can think about placing the event broker. So quite commonly, we will start small. We can start even from a single broker. It's not event mesh, but it's just a single broker. And then we can expand it. So we can keep adding event brokers, composing clusters of them. We will come to it, and composing the event mesh. So it doesn't need to be complex from day one. The complexity can rise as far as we increase the number of publishers, subscribers, and as far as we hit these kind of use cases. If we don't hit these use cases, then event mesh can be overkill.
That makes sense.
And with that, we come to the picture which depicts the overview about how the typical event mesh is composed. So we will see, or we will have several event brokers. These are runtimes. So these are engines that receive events, route it, and make it available for the consumer. In sake of high availability and scalability, commonly we may need to compose clusters of those brokers. So for example, we have some region, or we have some network location where there are lots of events that have to be processed through the event broker. And if one event broker is not sufficient, we can scale it. So we can add extra nodes of the event broker and compose the internal cluster. The beautiful part of the cluster is that all event brokers, all event nodes within the cluster will know everything about each other. So regardless of to which endpoint of which broker you publish the event, as a publisher, consumer will be able to consume it. It's not yet a mesh, it's a cluster of event brokers. When we come to the event mesh topic, this is where we connect several clusters, at least two clusters, into the mesh, into the grid, and this is where we explicitly set up so-called external links. So links within the nodes of the internal cluster, they're called internal links. So they are bidirectional, all nodes know about, everything about each other. When we set up inter-cluster connectivity, we compose event mesh, this is where we set up external links. And this is where we can define of which clusters of event brokers need to know about each other. So between which clusters we would like to allow this event forwarding. So in this picture, the left cluster is connected to the top one, and the right cluster is connected to the top one, but left and right clusters, they are not connected to each other. So if events will be published to one of them, they will not be forwarded to another one. Again, if we connect everything to everything, we may break the rule of compliance, for example. So we may become incompliant, which we ideally would like to avoid. And this is the cases where, this is one of examples where we may not need to connect certain clusters to each other. So to keep them disconnected. As far as clusters are connected to each other, then if publisher publishes the event on one cluster, to any broker of one cluster, this event will be automatically forwarded if there is a subscriber in a different cluster. And the keyword is dynamically. So we set up the link, but we don't need to set up any further forwarding rules explicitly. This happens implicitly by the protocol under the hood. And for publishers and subscribers, it also happens transparently. So for example, if we look into red colored stream of the publisher from top left, it publishes to the top cluster, and it doesn't know which subscribers consume for those events and where those subscribers are located. So one subscriber is top right, another one is bottom left, and there is another one in bottom right.
Oh.
So you see this red line, literally it's the one single event-driven flow where we have one publisher and 3 subscribers. All are located in different, for example, geographies or in different networks. Each of them is connected.
Does that mean that as a publisher, I may not, let's pretend I'm a publisher, I may not know the eventual end destination of a particular message I send on, because I may be sending to another publisher who then is sending to other publishers, right? There may be just like this sort of spiderweb sense of like, I don't know exactly myself. I may not know exactly where the last leg of the journey of this message is, right?
Exactly. Moreover, you as a publisher may not even know if there are those legs. So you as a publisher, you are not concerned about who are subscribers and how many of them are they in the enterprise and where they are located. So you as a publisher, you know that you produce some events that may be of interest and of value across the enterprise. You are authoritative publisher for those events, and you know that there is an endpoint of the event mesh or just event broker nearby to you, to which you can deliver those events. So you publish those events and you don't make any assumptions about existence, number, and locations of subscribers. It can happen so that it's
Sorry, I'm not sure if its analogy is correct one, but it's like in good old days of paper magazines and newspapers. As a literal publisher, you would publish your magazine, let's say, but then you would just give it to the distribution company, and then they would send it to maybe, and it would be like some person sitting at home, subscribe to your magazine, could be doctor's office, could be just end up, I don't know, some kind of mass event. Would that be kind of correct analogy?
Yep, that's a very good analogy. And in both cases, you as a publisher, firstly, you don't know where your magazine will end up.
Right.
And secondly, you don't know through which distribution channels magazine copies will be delivered to those subscribers. So you just know to whom you can hand over a batch of magazines, and then you assume that the distribution will happen magically.
Thank you.
Same as subscriber. Subscriber gets access to certain event types. It gets a subscription for those events. It gets connected to the event broker, but it doesn't know from where those events are coming. I mean, those events can come from the other side of the world. And subscriber will not know that. Subscriber will interact with the event broker that is nearby with a low latency, probably located in the same network from security standpoint. And all this routing mechanism between clusters, it will be completely hidden, completely transparent, both for publisher and for subscriber. And it's scalable. So if we start adding new event streams, new event types that we would like to publicize around the landscape, the cluster itself, the setup doesn't change. So we can keep adding new publishers. We may need to scale cluster. We may need to think about expansion of the event mesh, for example, by placing event brokers in some other far distant regions which are not covered yet, or networks. But it will be the matter of evolution of the mesh. It will not be a matter of complete redesign of the architecture of the mesh. So as you can see, in this example, we have very few publishers and subscribers, but you can imagine how this can help if we have hundreds and hundreds of them. And also, it can be not only internal publishers and subscribers. It's possible that we can get events from the outer sources, like, for example, stock exchange. So we can get some stock information from other sources, or weather forecast, some prices. And also, we can deliver events to external parties. So for example, we have B2B integrations, and it may happen so that external parties will be interested when something appears. For example, you go to the marketplace, you as a consumer, you search for some product, and this product is not available yet for you to purchase, but you subscribe to get notified, to get alerted when the product will appear in stock. What we will do is we will set up a simple event mesh, which will consist only of 2 event brokers. So we will compose 2 clusters. In each cluster, we will place 1 broker, and we will set up that link, external link, so that it's not only 2 clusters which don't know about each other, but it's truly the event mesh. Then we will have a publisher. In my case, it will be a CSV file that will be fed through Postman HTTP client, and we will publish it. We will publish events from the file into SAP Cloud Integration. It's a free tier sub account that I've created, and then in order to make it more interesting and more visual, we will have a lookup to the external service for geocoding information, so that for the amount of for events that we get from the file, those will contain information about cities and countries where SAP community events happened this year, particularly inside tracks and code gems. We will make a lookup to a geocoding API so that we can get geographical location of those cities. And we will bring those events, enriched events, through SAP Cloud Connector to our environment of event mesh. So we will publish just to 1 event broker. So as a publisher, we will be interested to publish to 1 of them. And we will have 2 subscribers. The first one is a tiny Go application, which is nothing more than a console application, and all events that it will receive, it will immediately show up in the console. And the other one is more sophisticated, so it will visualize events on the world map in Grafana dashboard. So we will have a world map, and then whenever event gets received, it will be processed through a workflow engine node-RED, just so that we can get that event and place it to the post it to the database. And database Postgres, it will be used as a data source for Grafana dashboard, so that as soon as the entry about the event is passed through and created in Postgres database, ideally it shall show up on the world map, and we shall be able to see colorful dots indicating where in this year inside track or code gem event happened.
This is a lot of goodies. I'm excited for this part.
Okay,
this is delicious. This is a good buffet.
Alex, this
Fingers
looks too
crossed it goes well.
complicated. I'm out of here. You guys have fun. So, Vadim, I'm just wondering if you want to mention why Solus is there instead of, say, like some SAP BTP stuff.
Yep. Good point. So Solus in SAP portfolio, we have SAP Advanced Event Mesh. So the word event mesh is quite overloaded nowadays in our ecosystem. So we have SAP Event Mesh, which we commonly refer to as SAP Classic Event Mesh. Then we got SAP Advanced Event Mesh. So those are product names, but the true event mesh as an architectural concept is what is offered by SAP Advanced Event Mesh offering in BTP. Under the hood, this service is fueled by Solus PubSub Plus platform. So it's another company which specializes on event-driven architecture and provisioning of capabilities for event-driven architectures. So Solus, the reason why we use Solus in here is because Solus provides a free version of the event broker that we as a developers, we can grab and deploy, and we can scale it, and we can compose event meshes out of it. The idea is that we can show something that we can run on quite tiny computers, and that we can run ideally for free. For Advanced Event Mesh, at the moment, SAP Advanced Event Mesh is not offered for customers or for prospect customers, neither as a free tier or as a trial. So if you would like to get a feeling of Advanced Event Mesh, you have to have a contract with SAP, and you have to subscribe for the paid service. Given that the technology in Advanced Event Mesh is based on the Solus, I took this as an example, because literally this will allow us to feel how this event mesh is composed, which technical bits we use here, and we can translate this knowledge and apply this knowledge further in Advanced Event Mesh. Just in Advanced Event Mesh, we have some extra capabilities like Event Portal, a web-based portal that makes this rendering of map where event nodes, event broker nodes are located more appealing to our eyes, but overall runtimes, they are same. And protocol support is also the same. And in this example, to make things even more complex, but also hopefully more interesting, most part of the infrastructure will be placed in Docker containers. So the deployment model of Solace and consequently advanced event mesh is based on containers. And in sake of demonstration, I also thought it would be a good idea to think about it as a disposable environment for our experiments as developers. So we can quickly create it, we can use it, configure it, run some demos through it, and then we can quickly dispose it and tear down. And if we will need it sometime later, we can again quickly recreate it once again. So in productive landscapes, commonly it will be Kubernetes cluster, but in our case, it will be containers running on Docker engine.
Docker engine, yep.
Awesome.
Let's get those goodies. Let's get those nerd things going. I'm loving this.
Go.
Let's do it.
To see you later.
I'm excited.
So what I will do is I will firstly look into what we're going to deploy. So BTP part integration suite and external service, they are already in there, they are already provisioned. What we will look into and focus our attention on is the Docker side. So event mesh components and subscribers that we talked about. So let me open it in VS Code. In sake of easier orchestration, I created a Docker Compose files for this, which means that the Docker Compose is the technology that sits on top of Docker, and it allows us to orchestrate different resources that we need to create or destroy as a part of the Docker deployment. In our case, we will have to deploy several containers. So we will have to deploy containers for event brokers. Then we will have to deploy containers for subscribers. We also will have to create volumes because some of this data will be persisted, and we need to have persistency layer. And we will also create an isolated network so that the exposure surface out of this Docker estate, it will be minimal. It will be just one single pod. We will not need expose much from this Docker estate. That's another part from security perspective, that we don't need to overexpose network ports. So what we have is, we have the main file, and I will deploy everything in one go, but technically we could deploy, given that Solace event brokers and publisher and subscribers, they're all independent parties. We could have deployed them separately. In my case, in sake of logical segregation and distribution, I just created a separate Docker Compose files for each of them, which are overall orchestrated by super one. So
you've composed the composes, as they say.
Exactly. Compose in Composer.
Yeah.
So it's a nice feature of Docker Compose, which was introduced quite recently. This includes so that we can compose a tiny Docker Compose elements files, and then we can bring them all together and include in the larger elements. So we can keep them quite modularized nowadays. So we have a broker. Effectively, we will deploy two brokers. So the first one will be for Europe, and another one will be for US. In this case, we take an example of geographic distribution, so that we assume that we have a publisher which publishes through European endpoint, and one of subscribers will consume from European endpoint, and the other subscriber will consume from US endpoint. And again, a bit of goodies from Docker, so we don't need to copy paste a lot of things. We can create a template for the broker that we would like to provision, with some entitlements for resources, like for example, for CPU and so on. And then we just create particular instances of those brokers. So you see, two brokers for UK, for EU and US, they are created quite compact, plus volumes. Then we have a publisher. The major part of the publisher sits in the cloud. It's integration suite, cloud integration in particular, but we will need cloud connector, so that cloud integration can deliver messages to the endpoint of the event broker. And this is where we have a Dockerized cloud connector instance that will be spinned up as a container. It's not officially supported, so for official deployment.
Yeah, I was going to say, you can't this is the part where we go, ooh, we're in uncharted territory here, because I can remember seeing lots of messages about, can I get a container for my cloud connector, and people are like, nah, not supported. So this is an exciting part of the discussion here.
Wild west of integration.
Yeah, the Wild West.
Yeah. Let's put a mandatory disclaimer here. So SAP Cloud Connector official deployment options, they don't allow deployment of the connector in a Dockerized or containerized environments. So what you see here is just for a demo and experimental purposes. And in here, moreover, the software components that sit under the hood of this Cloud Connector instance, they are also not supported by SAP. So there is a certain list of operating systems and Java virtual machines which are supported. But for this example, I needed to have something very lightweight. And for this, I used the concept of distro-less images. So literally, we don't use image, for example, of Ubuntu or some other system, but we go quite light with the base image. It's quite the trimmed version. And also we use a GDT, which is optimized for distro-less distributions. So it's not SAP JVM that will be used by this Cloud Connector instance, but it works. So for lightweight deployments, and here I wanted to show that we don't need significant horsepower to start with all, it works. That's for the publisher, and then we have subscribers. So we have a subscriber console.
Sorry, Vadim, before we move, I just have potentially very stupid question. So you showed us that kind of architecture before. It had like integration suite and then SAP like Cloud Connector. Like, what does Cloud Connector actually do for this? Because it's like, this is cloud integration already. I mean, by name implies it needs to integrate something. Why does it need separate cloud connector? And if it's too complicated to explain, please feel free to table this discussion. But I'm just kind of curious. I'm sure many people are going to be sitting there wondering the same.
That's a good point. Yeah. So a lot of things are in the cloud, and this Docker setup, it could have been deployed in the cloud platform as well. In my case, it will run on premises. On premises, like on the local computer. And given that we don't overexpose ports over the network, so there will be no much entry point into this isolated Docker network. So I needed to place a proxy somewhere within that Docker network that will be reachable for BTP, for integration suite, and that will be able to forward those messages, events to other components, in particular to event broker within the isolated network. So here Cloud Connector acts as a normal reverse invoke proxy. So it will, at startup of the container of Cloud Connector, it will make an outbound connection to integration suite tenant. It will set up a secure tunnel, and then whichever messages Cloud integration flow will send over, they will reach Solidus event broker through the Cloud Connector. So that will be the entry, the way how cloud integration that sits in AWS in my case, how it will be able to access a strictly isolated Docker network that runs on my machine.
Awesome. That makes
That's a very good point.
Yeah, thank
Given
you.
that it's Dockerized environment, technically we could have placed it elsewhere. So we could have placed it on clouds, on private clouds. We could have placed them in public clouds and so on premises, which makes this infrastructure even more transferable and reusable. So here we have a subscriber, which is a Go application. So that one is quite tiny. It listens for it establishes connection to the event broker, listens for events, and throws them into the console. And we have another subscriber, which is a dashboard. And here we have a bit more containers to spin up. So we have Grafana dashboard that will be our visualization layer that will show us a world map with spots. But in order to deliver those events to Grafana dashboard, I needed to use some more components. So the first of them is a database. So I use Postgres database because it's natively supported by Grafana. It's quick to spin up in the container environment. So it will be our persistency layer for events that will be further visualized in Grafana. And then in order to deliver those events and to save them in the table of the database, I needed to have some simple workflow engine where I used Node-RED So what it does is it will expose the endpoint, HTTP endpoint, to where the broker will be able to send events, and then it will trigger the workflow that will save those events in the database. What I wanted to show here is different mechanisms and different protocols through which publishers and subscribers can interact with Event Broker. So in case of cloud integration, the publisher, it will reach the Solace Event Broker through IMQP protocol. That's one of protocols that is commonly used in the messaging. So it will push events to the endpoint of the Event Broker. For subscribers, the Go application, it will pull events. So it establishes the connection at startup of the container via the native protocol of Solace, which is called Solace message format, SMF. And as soon as the event appears in the broker, in the relevant queue, it will pull that event. And for Grafana dashboard, it will receive events through push mechanism. So we have a webhook-based integration there, where Event Broker will, as soon as it gets the event which is of interest for Grafana dashboard, it will push the event, so it will send it over HTTP to the workflow, to the endpoint that is exposed by the workflow. So here I use HTTP, but in production-grade integrations, we will indeed use something which is encrypted SSL-based, so like HTTPS and IMQP over SSL. So here we are not constrained that we always have to get connected to the broker, or otherwise we lose events. And if application is comfortable to establish connection and pull events, that's absolutely fine. If the application is something that can expose an API and it listens for events to come in, that API is also fine. So we have webhooks through which we can deliver those events to the endpoint of the application. So here we have a freedom of choice, as well as we have different protocols through which this interaction can happen. So I will use IMQP, SMF, Solace native protocol, and HTTP for webhook. We could have used MQTT protocol as well, which is more traditional for IoT type of areas, but it's also supported there. Or we could use REST API of Solace. So we could invoke REST API over HTTPS to register our interest or to consume events. That's also possible. So you see, we have quite diversity of technology stack and diversity of techniques through which we will try to make this run end-to-end. And one other thing that I will drop in our Docker network is browser. So we will place a Chrome browser in the Docker network as well. You may ask, why do we need a browser in the Docker environment if we have a browser on our laptop? And here, this is a DNS question. So when we run containers, I would like to show something where we can use native names. Like, for example, we will use a name like dashboard, database, broker EU, broker US, rather than cryptic container names. And also, we don't need to mess up with port remapping and port forwarding. For this, normally we will need custom DNS or DNS entries on your laptop so that we know how we can make DNS resolution for those containers and port mapping, which adds extra either complexity for the developer or extra requirements like a custom DNS server. Here, I would like to keep it as lean as possible. So what I will do is I will place the browser in the same Docker network. In this way, it will be run in its own container, and we will access it through the browser. So it will be a browser in the browser. And then through the browser that runs in the container, we will be able to access all other components or most other components of our setup in quite native way using comfortable user-friendly names and default ports.
That's awesome. I've messed around with Docker and Docker Compose, and I've made some lightweight environments, and I never thought to create a browser container that I could mess with that stuff within. That's slick. That's cool. I like that.
Major today I learned.
Yeah.
Great. Well, it's not very common use case for Docker environments, but there is a family of images in Docker that are designated to desktop-based access. So you can think of some desktop systems environments, Office suite, and in my case it was browser. So it's not very common. So normally we would think of it as headless environment within containers, but that's also possible. That's also possible.
Beautiful.
Now, when we are done with the compose part, so when we start the compose, the Docker runtime will create all those containers and volumes and the network itself for us. So let us switch to Docker now. So what we will do is, let me open terminal once again. So I will connect to the machine, which is a single boot computer. So it's even smaller than the laptop. Where we will deploy all this Docker stuff. What I will use here, so firstly, we can check that we don't have any containers up and running. So we will create everything from scratch. The only thing that I did as a preparation is I pulled all images because some
Yeah,
images are
thank you.
quite heavy.
Yeah.
So just so that we will not wait like 5-6 minutes waiting until images are pulled. If this hasn't been done, no problem at all. Docker Compose will pull it for you. And all these images, they are in public repository in Docker Hub. So there is no need for any kind of copy from private repositories. Everything is accessible publicly. What I will do as well is I will use the tool called Lazy Docker just as a visualization layer, so that it will show up quickly what kind of objects were created within our Docker engine. So we see images, we see default networks in here, which are defaulted when we install Docker runtime. No containers, no volumes, and we will need an extra network, which is our network isolated for isolation of our workloads. So hopefully we will be able to see how this all spins up. This tool is a free tool. It's quite nice. I find it quite nice. It's a terminal user interface for Docker management.
It's beautiful.
I mean, any tool that has lazy in the name and gets my vote automatically.
Yeah. It jumps in my preference list as well, because if it's lazy, this means that it must be simple, it must be understood, and it may not require too many clicks to operate.
I can go take my coffee break now. Yeah.
Where is lazy SAP?
And what we will also do is on the right hand screen, this is my laptop. So on the left, it's the machine to which we connect probable deploy. On the right is where we have our infrastructure. I will again jump to the folder where we have this infrastructure. So we can see these are all files of the Docker Compose that we plan to deploy. Now we need to deploy them. So one of options is we can have SSH connection, so we can copy those files and we can deploy them. Or if we are in VS Code, then we can use extensions like remote SSH, so we can remotely operate with the machine from our VS Code environment. I will show another technique that me personally I found it useful as well, context. So in the Docker, we can set up different contexts so that if we have different Docker runtimes placed all over the place, we can connect to them from Docker CLI from our laptop or from some machine where Docker CLI is installed. So currently I have desktop Linux, which is the default one when we use Docker desktop on macOS environments. And I have already created a new context lab, which is the machine where we will make deployment. So what I will do is, and just to show that we're actually working with the different Docker engines, I will show you firstly, before I switched, that, sorry, typo, live demo, it happens, that there are no images on my machine. So it's empty at the moment, and there are also no containers running. So now I will switch.
This is the equivalent of when the magician goes, see, nothing up my sleeves, and then they pull the rabbit out of the, so there we go.
Here comes
it's now the part of the Reddit, right? So now you see I'm still on my laptop, and now if I will open list containers, nothing. But if I open and list images, I will see exactly the same images that I have here over SSH. So now, even though I'm on my laptop, my Docker CLI, whichever commands I will execute now in Docker CLI, they will be passed over SSH to the remote machine, and they will be executed on the remote Docker runtime, which to some extent can be quite handy.
Yeah.
So what we will do now is we will start deployment. Docker compose up, D for detach, so that we detach from the console output. So we will use lazy Docker for that, just so that it's more visual. And I will put no start so that it will create all objects, but it will not start containers. I will tell you in a second why. Technically, we could have dropped no start so that it will create all necessary objects and it will start containers straight away, but we don't want it. And see how quickly this will be spinned up. Done. So all containers, you see, we got a network where those containers live, and all volumes, they got created in a matter of 2.5 seconds. But they are not yet started, so they are not operational. And a reason for this is we have some there is some configuration which I needed to do, for example, to create a table in Postgres, to create a Node-RED workflow, to create a configuration in Cloud Connector. So I thought that it will be time consuming to recreate it now. So I ran it before. I made snapshots of volumes for those for those containers. And now I will just restore that configuration so that we can quicker move to the event mesh path. And here I will, for this, I will connect to remote machine. I will go to the folder. So that's the folder where I have backups of Cloud Connector, Node-RED, Postgres, and Grafana. For the dashboard, I will just recover those volumes. So because now we created empty volumes, we need to fill them in.
Yeah.
And for this, I have a small bash script, a shell script that can be used for bulk backup and bulk restore of volumes. So what I will do is I will just run it so that it will restore everything that it finds in the backup directory.
Yeah, so now you're just restoring those volume checkpoints into the actual volume space. Yeah, okay.
So we had empty volumes created by Docker Compose, but they are pretty much useless because there is no configuration in there. With this one, we just made, we took a snapshot of volumes, literally the same volumes that existed in the past, and filled, replaced volumes which were created by Docker Compose. Otherwise, it would be lots of manual clicks, which lots of time that I will have to spend to make that up manually. Now that's done with SSH. I can close this part, back to our laptop, and now we can start our containers. When they will start, Stolace containers, event brokers, they will start empty because we didn't configure anything, and backup, it didn't contain any volumes. For event brokers, we would like to make it to configure it ourselves. But all the rest shall start up, and we shall be able to see it. So what I will do is I will start Chrome. I will go to BTP cockpit of the tenant where integration suite is provisioned. And we will see that at the moment, there is no cloud connector connected to it.
And I just love how these pages ignore your dark theme. It's like every time, like, oh!
I try to use some extensions like Noir extension, I think it's called, for Safari, so that it makes sites a dark scheme, but sometimes it becomes, sometimes it's okay, sometimes readability suffers. So I thought I will go with just out of the box color schema. So we have sandbox environment sub account. We go to connectivity, to cloud connectors. And you see currently nothing is connected there. So cloud connector is not yet there. Now we make Docker compose and we do start. So what this will do is it will just start all the containers that we have already created with the previous command with up. And again, let's see how quickly it will do it. Done. Another 2.5 seconds. And the first error to which we will get, that's a good error. What we will see now is if I refresh the page, now the connection is up and running. So it was connected, and if I were to connect to the Cloud Connector admin UI on the machine, we would have seen that the link was set up, the tunnel is up there. So now Cloud Integration shall be able to reach Node Broker EU. So we will be publishing to European event broker. So what we do next is we explore why the error happened. Let's go to this Go application. And it failed because the application started. It wanted to connect to the broker. It wanted to read events from events SIT queue, but at the moment our Solay setup is it doesn't exist yet, so it failed. So let's keep it here. I deliberately didn't make configuration to restart it automatically because we will take a few minutes to set that up, and then I will restart the container manually so that it will get connected. But while we are here, what we will do is now we need our magic. Now we need container in the container, a browser in the browser.
Browser in the browser.
And it should have been HTTPS. There we go. That's fine. Let's ignore it. Certificates. It's the default user. So it's based on the technology called custom VNC. It's not the traditional VNC that you may have used for remote connectivity. So it's the protocol that is optimized for this kind of placement of the graphical user interface in the Docker environment and then exposure of this interface outside of the Docker. So we are now in the Chrome and we are connected to another Chrome in the Docker. So this is now we are connected to the container, which is our browser container. And here what we can do is we can, for example, go to Node-RED. So it will be subscriber dashboard 1880 port. So we can see this is the workflow that will get triggered for US. So for European EU broker, it's Go application, which is currently in error state. This is the listener port. So event broker will send events to the endpoint cities. And then this workflow, there is some logging in here, but ultimately what it will do is it will, for every event received, it will add an entry in the database. In Postgres, we can have a look in Postgres database as well. So let me start the shell in the container. So now we are in the container of Postgres and PSQL demo. And then we can see the table. I called it cities. So that's the table that was also created and which I restored from the volume. This is the table to where the workflow will write details about the city so that this data will be further visualized in Grafana dashboard. And for Grafana dashboard, I have a bit longer URL, so I'd rather copy it and place it in here. Grafana. You see, we have a dashboard which has only one panel, which is world map, and at the moment it's empty. And this will be fed by entries from the database. So it looks like it's okay. The last thing that we will check is integration suite. The integration flow, it existed, so I deployed it in advance. So it just existed and it was operational in the sub account. We will just see and make sure that all steps are in there. So we have the endpoint.
API,
geocoding. We have the endpoint to where Postman will send, then some parsing of the event that comes in, because the event that comes in, it will be quite tiny. Then we make a lookup call to Geo API to get geolocation of the city by the city name and country. And then we compose publication to the broker. And then via Cloud Connector, the event will be published to the broker. So looks like we are okay with that part as well. Let's close this part. And now we need to come to brokers. So now we need to set up queues. So the idea is that the publisher will publish events to topics, to a bunch of topics. And then for each subscriber, we will create a separate queue from which that subscriber will read events, or from which events will be pushed to the subscriber. So that for different queues, we will be able to set different filtering criteria. And this is something that I'd rather visualize. So what we will have is we will have a composite queue, so, events that will be common start point. Then the next part of the topic, sorry, not queue, topic. The next part of the topic will be the type of the event. So for example, we will have inside tracks and we will have code gems. And then the subsequent part of the topic name will be indication of the country. So it can be, for example, US, it can be United Kingdom, it can be Belgium for code gems, it can be, for example, Germany, it can be US as well, and so on and so on. And within the event, so events will be published to topics, for example, events/inside track/US. And then in the event, it will be indication of city where in the US the event happens. This is also quite nice feature of the Solace and advancement mesh that it supports a hierarchy of topics or topic taxonomy. So quite commonly, when we come to the flat list of topics, all events of specific event type, like for example, sales order created, they will be published to the same topic, regardless of from which sales organization it comes, from which for which customer it comes. So all events, they come to the same topic, and then we need to somehow filter them because probably not all subscribers need to get all those events. Firstly, because maybe they are not allowed, they shall not be allowed to get all those events. And secondly, even if they are allowed, not to make overconsumption on their side, so that they don't need to consume and filter on consumer. And commonly, when we have flat structure, this is, for example, how classic event mesh operates. We publish events to a single topic, events of the same events type, like, for example, all sales order created events. And then we put a middleware that will make this kind of filtering. So, for example, we put cloud integration in the middle, which consumes those events, makes routing and filtering, and then republishes them to different queues for different subscribers. In here, we have a kind of a tree structure of the topic. So each of these levels, and we can go further. So for example, for the sales order, it can be sales orders, then we can indicate a region or country, we can indicate a sales area, we can indicate a sales order type as a part of this composite topic name. And then we can filter within the broker using these elements of the topic, which means that the publisher is not concerned about filtering on the publisher side. Also, filtering on the publisher side is also one of cases where we may need to trigger it so that we don't publish too many events, don't become too chatty. But even if the publisher is generic and if S4HANA publishes all events about sales orders, we can be smart within the broker to filter those events as soon as we design the topic name, the levels of the topic name based on the attributes of the business object that we would like to filter on in the future. And this is where we can provide some examples. So for example, we have this structure and we would like, for example, for one of applications, we would like to consume all events, which means that all types of events coming from different countries. So there is a shortcut for this. This means that we consume all events. For another one, we may be interested in consumption of all events from all countries as far as those are inside track events. And then we will do something like this. For the third one, it can be that we are interested, for example, the subscriber is in Germany and we would like to receive all events which are about German SAP events. So then it will be something like this. Or for example, we can say we would like to receive all events which type starts from code and, for example, from events that happened in the US. So we will say code, Sterix, US. And here I only had effectively two filterable levels. So the type of the event and country of origin of the event. You can imagine that in reality, we can have 5, 10 different attributes that can compose a topic. And these all, for example, events inside track US, that's all, it's a topic name, the way the publisher will publish. And then we can do filtering. So depending on the subscriber needs or compliance requirements, we can be flexible. So this composition of the topic name as compound of different attributes that make sense to that specific business object and that shall be filterable. That's also one of the nice features that Solid provides. At the moment, S4HANA, it can the most recent releases of S4HANA, they can natively talk to advanced event mesh as well. But at the moment, they don't support the so-called topic taxonomy. So that's the publisher who shall know to which topic it shall publish. So the publisher shall say that I would like to publish to this topic or to some other topic. Currently, S4HANA doesn't know how to use this topic taxonomies, but there is some intention to introduce this feature in the future. I haven't seen it in the roadmap, but when we discussed with the project management, definitely they shared the interest to allow S4HANA and other SAP systems publication to different topic taxonomies.
That only makes sense. I think that'd be a
Yeah.
great add-on for sure.
It also what existed before with IDOC interfaces. I'm saying this, yeah, it used to be filters where you had to select and you could combine criteria, etc. So yes, there are a lot of similarities.
Back in my day, we could send
Well,
IDOCs anywhere.
We had to set up filters
And we still
manual.
can do.
Yeah, exactly. That's the beauty of it.
And you will be used. I'm speaking about events, but Solis is a general purpose event/message broker. So it has we can send quite large messages over advanced event mesh or Solis. For example, in classic event mesh, we had a limit of 1 megabyte per payload. Here, this limit was lifted. So we can wrap IDOC and send it as a message to Solis and then make some processing, some routing of the IDOC. It's not very traditional flow, but it's technically possible. So when I speak about events, they are quite lightweight. So it's not the entire, normally it will not be the entire state of the object, like all attributes. But technically, we can treat Solis as a general purpose event/message broker. So we can pass messages as well and use these capabilities for messaging. So in my flow, this composition of the topic name is something that a cloud integration does. So in Postman, I will feed a list of CSV, a CSV file, and then a cloud integration will do parsing of the CSV data and composition of the topic. Ideally, the publisher or the publisher domain shall be responsible for this kind of composition. So different events, in my case, they will come to different topics. So if I make a step back, and if I look into data source that we will feed into, this is the data that we will send through Postman to cloud integration to the iFlow. And then based on the type of the event and country, it will understand to which topic the event shall be published. So now we are done with that, but now we need to go to the broker because we haven't yet set up broker. None of them. So what we will do is, firstly, we will go to the European broker, to EU. Here we go. Now we are in Solis UI, and Advanced Event Mesh looks very similar from UI perspective. So look and feel in the cloud part, it's a bit nicer UI in my personal taste, but the overall composition is very similar when we come to configuration of the broker. So as I mentioned, we cannot connect the broker directly into the mesh. We firstly have to create a cluster, internal cluster, and then we connect clusters for the event mesh. So I will open the first broker, and I will also open the second broker, the US broker, side by side.
But would it be possible to zoom in maybe a little bit? I think the text is getting a little bit too small from my eyes, at least. Yeah,
yep,
perfect.
sure.
Thank you so much.
Let me make it. Is it better?
Yeah, much better. Thank you.
I will make this larger as well.
Sweet.
So we have EU and we have US. So now we will start from EU and repeat similar setup for US. So we go to clustering. Oh, let's make one step back. So we first will create queues. So we create a queue. And here we want to create a queue called events SIT. So this is the queue from which our Go application will consume events. And now the queue has been created. Already now I can, okay, I will quit this one. I will go back to lazy Docker. I will already restart now, and let's see, go console application. Now you see that after I created the queue, now the Go application is connected. It connected to the European broker, and it's ready to receive events from the events seed queue. But Cloud Integration doesn't knows nothing about this queue because it doesn't post the queue. It publishes to a topic, and this topic to queue mapping, it's very common nowadays. So from one hand side, we can publish to a topic and we can subscribe from a topic, which is common for broadcasting flows scenarios, but topics, they don't normally persist messages. So if the subscriber is not online, it will miss the event or the message. Another part is queues. So the producer can publish to a queue and the consumer can read from the queue, which is great because queues are persistent. So if the consumer is not connected at the time of publication of the event, it will receive that event when it goes up. But queues are common for point-to-point, so for one-to-one. So they are not very common. They are not intended to be used for broadcasting flows, where publisher publishes the event and it gets spread across several consumers. Sure. This is where topic to queue mapping helps us. So we have topics to where publisher publishes, and then we have a broadcasting type of scenario, and we have queues from where subscribers will read those events. So in that sense, we can create multiple queues, and if subscribers are separate, isolated, then we will create, well, let's say not isolated, but if they are not used as a cluster, but if they are distinct subscribers, like our case, for each of those subscribers, we will create a separate queue. And then we will map events from the same topic or topics, as in our case, to different queues using different filtering criteria. So for example, for Go application, we have a queue called events seed. And now we would like to route events, only those which are related to inside track events. So we go to subscriptions and we create events inside track from all countries, which means that whichever events or whichever occurrences of inside track or code jam events will be published by Cloud Integration, this queue will receive events only for inside track events. So the consumer will not be able to overconsume or to read extra events because it will just not know that other events exist. Note that we created queue explicitly, but we didn't create topics explicitly because topics are dynamic. So we don't, it's not the object that we have to maintain because we can have thousands and thousands of topics. Even for this example, we can have tens and tens of them, different countries, different event types. So it will be quite cumbersome to maintain all those topics in advance. So topic is the attribute of the event. It's not a configurable object, as opposed to queue, where the queue is created in advance. So we create this one. And what we will do is for US, we will also create a queue so that our dashboard will be able to receive cities. Also, exclusive means that we will expect just one consumer to get connected or to receive events from this queue. And this one will be interested in all events of all types and coming from all countries. So you see that even though they will receive events published to the same topics space, queues are named completely differently and filters are different. So every subscriber will not know about existence of the other one. Here, it's quite important to have proper naming conventions, both for topics and for queues. And also what we will do in here is, given that for US, it's a push mechanism. So we will need to set up this connectivity to the endpoint of Node-RED workflow. So for this, we have clients. So within the event broker, we will be able to set up this webhook from the queue. So I will create a REST delivery endpoint, workflow platform. Create. I will enable it straight away. It's Node-RED. Apply. It's a bit of configuration. I will try to be quick with the setup. So REST consumer, it's dashboard. Enable. The host is subscriber dashboard. That's the one where our Node-RED workflow sits. Dashboard, and the port is 1880. And I set it up not to require any authentication, just in sake of simplicity. Apply. Done. And for queue bindings, we say that the queue that we create is cities. We would like events that come to this queue to get forwarded to the URI cities. So cities URI is what our workflow, Node-RED workflow exposes. Apply. Summary. So we see that all is up. So event broker, we have a queue. We have all events that will come to this queue, and this queue, as soon as it gets the event, it will try to send those events to the given endpoint. That part is done. Now coming to the event mesh. Now we have two different event brokers which don't know about existence of each other. So they have queues. We can get connected from subscriber side. We can publish to those to the topics, but it's still not mesh. It's just two brokers that live their own lives. Now we need to create a mesh, and this is what we will do. So we go back. I will start from EU broker, and then I will repeat steps. So we firstly create internal cluster. So we have to create two internal clusters, one for EU, another for US. Create cluster. I will not be creative with the name, so I will just call it cluster EU.
Works for us.
It's you can see how much brain power I invested into naming conventions.
I mean, that's one of the hard problems in computer science, right? Is naming things. So just go simple.
Oh my gosh. Yeah,
Oh, yeah.
exactly.
So that one is done. It's spread. I will just refresh it, and it shall turn green. So one cluster is ready. It's a stronghold cluster. It's just one single event broker which sits in it. And if I were to add extra brokers in this internal cluster, then I could have done so in internal links. So I can keep adding extra clusters to extra event brokers to scale that cluster. But in our case, it will be just one node. And I need to do something similar.
It's clusters all the way down, clusters of clusters.
Clusters of clusters, yeah.
Clusterpalooza.
The US. This one is done as well. Here we go. So this shall be up again as well. So now we have two clusters. Nice, but they're still not talking to each other. Still not event mesh. Not good. Let's build event mesh. So we go to external links now. So we don't have any internal links, but we will set up external links between them. And here we have several options how we can do it. We can do it via CLI. I will do it via UI. So there are a few warnings because I don't use TLS. So it wants me, for the sake of demonstration, it shall be fine. Continue. And here we specify those links. So from which party to which party we would like to connect. And this is where we can connect either from the remote broker into ourselves or from us into the remote broker. Commonly, it matters what kind of network connections are allowed. For example, are inbound connections are allowed into this broker or just outbound connections are allowed. In here, I'm quite indifferent because both brokers, they are in the same network and both inbound and outbound are allowed. So I will set up connection from European broker to the US broker. And it was this one.
I think if I may notice, kind of UI is really nice in this system. Like when you enter URL, it has like HTTP in front, so you know you don't need that part, and this kind of graphical schematics is also nice.
In the cloud part, in the event portal, it will even be able to render those event brokers on the world map. So you will be able to see in which hyperscaler the broker runs, or is it on premises. So for example, you can have a mixture of brokers deployed in Asia, AWS, on premises, and so on and so on. And then on the world map, you will have like a single pane of truth. So we get connected. Let's proceed. A bit of authentication. I use basic, but in the real world, we could have used some identity provider for brokers. Fingers crossed it works. If it will work, this means that we created an event mesh.
I mean, this is the moment, guys. This is the moment of truth.
Yeah.
If this
Oh, yeah.
if this works, we have a mesh. If it fails, we just have we have a mesh.
Boom.
Great,
Boom.
great.
Whew. You had me worried.
Thanks
too,
to
but,
everybody
we
who
pulled-
kept their fingers crossed. So now we can see, I will just slightly zoom it. So we can see now the rendering of the cluster. So we have cluster EU, cluster US, they are connected. Again, this is the event broker UI in the event portal, the cloud path. You will be able to see it on the world map with indication of hyperscaler, so on premises, but roughly the idea is the same. Great. So now we have brokers set up. Event mesh is ready. And I think this is now the moment of truth to run it end to end, to fire Postman and to see if we have any visualization in Go application and in the world map. So that's another moment of truth. What I will do is I will put it side by side so that we can see if something appears in both of them. And
Right
in
on.
Postman, I will start our event generator. So firstly, it's auto protected, so I will need to get a fresh access token so that we can call our iFlow in cloud integration. And now we start execution. So we will pick up this file, which I mentioned. It's a CSV file, but subscribers, they don't know that actually the source of events is traditional CSV. They may assume that it comes from some fancy HTML5 application sitting somewhere in the cloud. And I will just put some delay so that they don't show up all instantly. And here we go. So they started to go. And we will see if something pops up. You see first dots they started to appear in the dashboard. So it's, and you see that here we have some indications, but our Go application was quiet for quite a while because dashboard, it was interested in all events, but Go application was only interested in inside tracks, or was only allowed to get information about inside tracks. And given that in the file we have quite a lot of code gems, they will only appear in the dashboard, but not in the console application. So we can see that all these dots are inside tracks or code gem events that happened this year all over the globe. And as you can see, CPI, it was publishing events just once for every line of the CSV. So it published to the broker in EU, and the Go application was connected to the broker in EU. And whatever happened in the Grafana dashboard, it was the consequence of the event mesh. So the event mesh understood that there is a subscriber in US who is interested in events. And it, given that even though the event was sent to the event broker in EU, it was forwarded to the through the external link to the event broker in US. And then it was forwarded through webhook to Node, read, persisted in database, and visualized in Grafana dashboard. So this event, which came from CSV file, it actually traveled quite a while until it appeared as a dot on the Grafana dashboard.
Beautiful. It's beautiful. This is frankly pretty awesome demonstration here of this stuff.
Yeah.
Yeah.
Yeah, I know.
One other thing.
No, I just want to say we joked before about different excitement scale for like Russians and Americans. And Russia is here and US is somewhere like way high, but I think even on Russian scale, this is really, really great. Excellent.
Yeah.
Thank you so much, Vadim. Yeah. Please, sorry, interrupted you.
Yeah, sorry. I did like, I'm so glad to watch all of the little like building blocks stack up to make the thing, you know. This is great.
I'm so glad it worked, because the moment of truth when you click send in Postman and you open Grafana dashboard. One other thing which I didn't showcase here, but which is not related to event mesh, but it's a feature that is supported by Solace. it's useful for event streaming flows. So in Solace, we can record. So here we persisted events in the queue. So if the queue gets disconnected, the subscriber gets disconnected, they can still consume from the queue afterwards. There are cases when we would like to replay events. And Solace also supports those type of integrations. We don't need a publisher to resend those events. We can enable a feature in the Solace broker, which is called message replay log. So all events that pass through the event broker, they will be persisted in its own persistence layer. And then if, for example, we create some new queue, some new subscriber, or if subscriber lost events, we can replay from the event broker. So that's it's something that I haven't shown yet, but that's another feature that can play nicely with the event mesh as well. When we speak about volumes and scales and about dynamicity of publishers and subscribers, this event streaming capability is also in there. So even in this version that we deployed here, we could have also enabled message replay log, and then we could replay those messages. What I wanted to show you as well is we now have quite polluted environment. I mean, we have quite plenty of containers and data flying here and there. If we are about to wrap it up, so we can literally shrink it and tear down in a single command. So docker compose down, and I will put it v as well to remove to delete volumes. I could have put RMI to delete images as well, and you see how quickly all the demo infrastructure that used to run in the Docker will vanish. So take a bit.
First you summoned the genie earlier, and now we're putting it back in the lamp, right? There we go.
So some containers, they take a bit longer to get stopped. Now you see like 22 seconds.
Oh,
and we're back to
look at that.
One
A beautiful blank page. Beautiful.
So that's another beautiful part why the demo was in the Docker, that it was hopefully relatively quick to create it. So that's a subjective judgment, but you saw that it didn't take hours and hours to set up, although some things were done in advance. But I must admit that creation of the Grafana dashboard with a single boot map and cloud connector configuration, it's not the true magic. So, I mean, it takes some time, but it doesn't take fortune. The majority of infrastructure we spin up in a matter of few seconds. I spent more time in the web UI to set up queues and to set up event mesh and so on. Again, something that we normally wouldn't need to create too often for demos, although we can scale it. And then when we are done with all this fun, we just decommissioned the entire Docker infrastructure in a single command in a matter of few tens of seconds, less than a minute. And we are back to the clean screen, and we can recreate it again if we need to do so. We can adjust it, or we can bring it to another machine and run it there as well. So it's quite disposable and it's quite transferable. I think that's also another part that really shines.
Absolutely. Well, Vadim, this is just, I mean, you're knocking my socks off here with all this cool stuff. And I know we gotta kind of keep our time hats on here too and make sure we're doing okay. Is there anything else you'd like to promote or tell our watchers or listeners about real quick, about any other projects you're interested in, or anything other thing that people might want to know about this stuff?
I think it will be very useful for those who will get excited and interested in this topic. Whenever you think about advanced event mesh, think about Solace. So a lot of educational material, a lot of tutorials, they are in SAP, but they are also in Solace. So go to Solace PubSub plus platform documentation, have a look into there. They have nice tutorials about deployment, about the use, about capabilities of event brokers. So in here in this demo, even though I tried to showcase some nice features, I literally just scratched the surface. So there are more things that we can play around, and with this flexible topic taxonomy, or with a scalable setup of the events of clusters and event mesh, with replay log, cloud part, event portal, it also adds a lot about metadata management. So literally all those events that flow between systems, they can be visualized. So we can have a graph-like UI where we can see which publishers publish what type of event types and which subscribers are listening for those events. So what I showed in CLI and in WebUI, it can be nicely visualized in graph-based view, and it's quite self-service friendly. So the intention is that it's not a technical, well, it is a technical, the setup is technical, but what we can consume, what we can use in business flows, it's quite centric for the application domains. So if we think about what types of events we would like to publish, we would like to socialize across other systems, or we, as a publisher, or which events we may be interested to consume and process and react, all those things, they are not that technical as CLI thing, and they come from WebUI, so they can be visualized nicely. They can be monitored nicely as well. So from perspective of event flows and event streams, it's very scalable infrastructure. So we had just one publisher and 2 subscribers, but it can be hundreds, if not thousands of those.
Yeah.
Yeah.
So the blob, it can expand and expand. We can have a lot of use cases for different types, and also the combination of enterprise IT events and IoT like events, for example, events coming from machinery. There are protocols and capabilities to support both worlds in this event broker. I wouldn't say that this event broker is one to rule them all, but at least it has support. So there are some other brokers which are more tailored, for example, for machinery events, but those events, if we have some flows where enterprise IT and operations IT, like machinery, they have to collide and they have to cooperate and coexist and react to events of each other, then there is some common ground for them. There are some event brokerage capabilities that can be leveraged by both worlds.
Beautiful. Well, on behalf of us, on behalf of anybody who's watching, on behalf of people subscribing, Vadim, truly thank you for taking us through this, for prepping this. This was like a beautifully laid path for us to walk down and smell the roses and observe the other flowers. And it was amazing. I loved it. I loved it.
Yeah, it's really
Thank you so much.
tremendous. Yeah.
Yeah. So
thank you for your time.
Yeah. On behalf of the Burning Enterprise Nerds, thanks everyone. Please make sure to click subscribe and all that kind of stuff, and do it all that other good stuff.
Like and subscribe.
Yeah, please like and subscribe. And we'll catch you next time, guys. Thank you.
Thank you.
Thank
Bye.
you. Take care. Goodbye.